Good morning everyone. Let's continue with momentum, and today we're going to look at impulse. We talked about already that you can change the momentum of, let's say, a tennis ball. Coming towards you, I'm going to hit it back. Now today I want to ask the question, how? How are you going to change that ball's momentum? Alright, just look at a tennis player waiting for a ball to be served towards him. So let's say now I'm waiting for the serve of Nadal or Roger Federer. So that ball is coming towards me at a certain velocity. I'm going to use my tennis racket to change the velocity into the opposite direction. So what do I need? Force. I have to use that tennis racket of mine with force, with a certain amount of newtons opposite direction to change it. But you know what? If you were a tennis player, like I was when I was young, they taught me always to say, you know what, you've got to hit the ball through. What does that mean? It means if I get the tennis ball there, so the tennis ball is coming towards me. Now I have to use my tennis racket, get the ball on the racket, keep it there as long as possible, and I'm going to hit the ball through. So I extend what? The time that I apply the force. So if I'm going to look at a change of momentum, I want something to change its momentum. Then I need to apply a certain force. Yes, of course, it's a net force. It's the winning force. So after I've deducted whatever air resistance or other forces they might be working against me or with me. So it's my net force times the time that I have on the ball, on my racket. If I would just push out my racket like this and apply the force, not that much change in momentum. The ball might just bounce, 2 meters in front of me. But when I prolong the time, so I extend the time, then the change of momentum gets so much higher. So it's both these two together. Now what do we call this? This force over a certain time to change something's momentum. We call this impulse. So, strange word for me. So you have to apply impulse in order to change something's momentum. Now that is quite an interesting thing to think about. So if let's say I want to change something's momentum and my momentum would be equal. So I want to change the momentum with, let's say, 10 kilogram meters per second, just a number. These two together is going to make up the 10. So you see, if I have a huge force, then I only have to have it on my tennis racket for 1 second. But if I'm not that strong, I only can apply, let's say, 1 Newton force, then I better keep that on my tennis racket for 10 seconds to get the same change of momentum. Now I'm going to tell you a quick story. I had a small Mini Morris as my very first car. But I mean really vintage, small little car made of iron. I'm sure it was made of iron, because I could have a party on top of that car's roof and it won't bend. Later years, when my daughter turned 18, we got her a nice new car. And of course, today's cars are not built the same. So she was not even in a really much of an accident, and they wrote that car off. And I was so upset. And I was like really fuming and saying, you know what, they don't build cars the same than in the old days. You know, these days you just look at a car and it's got a dent in it. True, eh? But then I started to think, you know, using a bit of my science brain there. And I realized the reason for it. If I would be in my Mini, driving towards a wall, and I come to a standstill against the wall. So again, let's say my change in momentum is 10. Alright? Now with my Mini, which is such a strong iron car, I will hit it bang There won't be any resistance, nothing. So my time would be probably 1 second and then I come to a standstill. But what would then be the force of the wall on me? That will have to be 10 newtons. You see? So a lot of force is going to be applied on me to be able to stop in that 1 second. And I'm not going to walk out of there alive. Whereas with my daughter's car, the new modern cars, what do? They build in something so that it starts to give way. So as she hits the wall, or she would hit the wall, the car starts to crumble up. So the time for it to come to a standstill gets increased. That means, let's say only to whatever, let's say 5 seconds instead of 1 second. But what do we see now? Now the net force working on her instead of 10 Newton is only 2 Newton. So although the car is a write-off, she climbs out and she's perfect. And oh my goodness, that is the reason why. Let me tell you another example. You know these parkour guys, I don't know if I say that right, they're going to kill me for how I pronounce it, but it doesn't matter. You know, they can jump and fall from anything. If I would jump from, let's say, the 2nd story of a building, and I would jump with my legs straight out, like this, it's just going to be breaking. I'm just going to end up in the hospital. But what does these guys do? They jump, and the moment they hit the floor or the pavement, they're going to just start rolling. So they give way and they start rolling. So what do? They extend the time. So that the force working on their legs are almost nothing. Whereas with me, legs stretched out, keeping it like that, instant. 1 second and I break all my bones. So that is the difference. You see, so we apply again impulse. And that is an important question they might ask you. You know what, why do I throw an egg against the wall and it breaks? And I throw that same egg, but let's say against a sheet, something that gives way, that egg just rolls off. Explain using physics. So that could be a question of almost 4 points. Now how do you explain in physics something like that? Always start with a formula. So you're going to write down the formula and you're going to explain in that question that for both to make the egg come to a standstill, that's what you're aiming for, you're going to have the same change in momentum. So let's say the speed goes from 10 meters per second or whatever to 0 in both cases. But in the case where you throw it against the wall, the time of contact is very small. So the force has to be so much higher to give the same change in momentum. Whereas if you extend the time, where you have, let's say, a sheet, and the sheet is weighed and comes back, you extend the time, smaller net force, and the egg doesn't break. So always explain any physics question very much with a formula. And this we're going to call impulse. Now what is the unit for impulse? Let's have a look. The unit for impulse, what do we measure Newton in? There I'm saying. Force, we measure it in Newton. We measure time in seconds. So now it's not Newton per second, it's Newton times seconds, so Newton seconds, equals kilogram meters per second. Now I always like to play around with units. You will soon discover that from me. So I want to know, is this really the same unit? Where does that come from? A Newton second equals, it's the same as, okay, let's have a look. How do we measure a Newton? Can you remember from grade 11? Grade 11 we said F net equals MA. And how do we measure a MA? So 1 Newton equals 1 kilogram. And what acceleration we measure in meters per second squared. Now if I would put that unit instead of the Newton, you see that I've got a kilogram, I've got a meter, and then I've got a second minus 2 square times seconds. So one of them is going to cancel out, and I'm left with just the one, and there we go, exactly the same unit. Alright, so where are we going to use this? We're going to use impulse. They're going to either ask that directly, work out the impulse, or they might ask you, what was the net force applied to change the tennis ball speed from, let's say, 10 meters per second into the opposite direction to 8 meters per second, and in a time of 5 seconds. So you see, we're going to use then this formula, my impulse formula, to work out the force if you have the time and you have the change in velocity of a certain object. So I'm going to show you. Let's have a look at maybe one question, or that I'm going to do maybe in the next video. So I'm going to show you how are we going to look at doing, or how would such a typical question looks like. Alright, let's have a look at a question out of a previous matric exam paper. Alright, the question goes like this. A ball with a mass of 100 grams, okay, careful, 100 grams. We know we can't work with grams in physics. We're going to change that to kilograms, so divide by 1,000, so that gives me 0.1 kilograms. Alright, so that's the mass of a ball. It's moving horizontal, and it with a speed of 10 meters per second, and it says it rebounds at 8 meters per second. So it hits a wall, it rebounds at 8 meters per second. Alright? So you immediately see you've got mass, you've got two different velocities, and that should immediately, alright, remind you that is change in velocity, change in momentum. Alright? And then they say it is in contact with the wall for 0.01 seconds. And the question is, calculate the average force exerted by the wall on the ball. So, very important. If that is the wall, they ask the question, what is the force that the wall exerts on the moving ball? So here we've got your formula of impulse. So there's your F net, that's the one they're asking. They do give you the time, and they do give you a change in momentum. Very important, guys, very, very important. What do you do first thing before you start doing this problem? You choose a direction. So I could say, let's say the original direction, or the ball is moving east. I could also say to the right. And that direction I'm going to choose as my positive direction. And now in my next step, what do? I'm now going to put in, so I'm looking for my net force times, do I have the time? Yes, 0.01 second equals, what is my change in momentum? So my change in momentum would be my mass times velocity final minus velocity initial. What is my mass? 0.1. What is my final velocity? Careful here, it's moving in the opposite direction, so I have to use minus 8 minus the original velocity of 10. So you can see I've got minus 18, and now I'm going to have that divided by, let's take that across, and that would be my 0.101 seconds. And if I work that out, let's just quickly get my, let's see that 1 times minus 18 divided by 0.01, and I get what, minus 180 Newton. So the minus actually means if I choose as a positive direction that direction, then what the minus in this case means opposite direction. So the net force by the wall onto the ball is 180 Newton, and now I would say west, or opposite direction. Guys, I just want to tell you, when there's two different things with impulse. There's always the thing that you change the momentum of, and then there is the thing or the object that exerts the force onto that object. So there's two objects. And because this force gets applied onto one by one of the two, the same Newton free apply here. So if you have an impulse or a force onto the wall, then the wall will also have a force or an impulse onto the ball. So why do I say that? If you get, for instance, something, an exam question where you have to work it out, but you only have the ones change in velocity and not the other one, then whatever, you can use that one, just keep your direction that you know in which direction that force is going to work. So you could work with a change of momentum of either one of the two. Of course, in this instance, it's the wall that is standing still. But the wall does exert a certain force in that direction, but it then also means that the ball exerts an equal force into the opposite direction. Alright, so go and practice, because the more you practice, the better you get at it. Who said that? Gary Play. Right, believe in yourself, you can do this.